Okay, so now we're going to be doing question 4c. Now this question relates to a particle moving such that its acceleration is equal to its 18x cubed plus 27x squared plus 9x, where x is its displacement from the origin. Initially, so that is when t is equal to 0, we know that x is equal to minus 2 and that v is equal to minus 6. So the first part of the question asks us to show v squared is equal to 19x squared plus 1 plus times 1 plus x squared. Okay, so how do we do this? Well, we know our standard identity that you should have learned, that x is equal to, the acceleration is equal to d over dx half v squared. Okay, so we're going to use that because our acceleration is in terms of x, but we can't straight up differentiate. And also that v squared is in this equation. Okay, so we're going to replace x double dash with this. Okay, so the next step is we're going to integrate both sides with respect to x. So as you can see, if I multiply that side by dx, so we're going to get that half. Oh, sorry, no. Okay. So we're just going to get so as you can see, I'm integrating this equation, because if you imagine dx comes over here and that leaves nothing over this side of the equation, so we're just left with this, and we've also got to add a plus c here because we've already integrated this technically, so we've got to have a plus c here. Okay, so now the next step is to continue the integration. So now we're going to have 18 over 4 x4 plus 9 x cubed plus 9 over 2 x squared plus, now we're going to introduce a new constant now because there is also a constant here, so we'll call it k. Okay, so now that that's done, we'll now use our initial values here so we can find this value of k. So when x is equal to minus 2, v is equal to minus 6. So half minus 6 squared, and now we just substitute all this in. This will give us and then that will be equal to therefore k is actually equal to 0, since 72 and 72 cancel out and 18 and 18 cancel out too. Alright, so that part of it is done, and I've lost the thing. There it is. So now we know that k is equal to 0. So now all we have to do is now take k away because we know it's equal to 0. And now we just have to factorize now. Okay, so I'll multiply everything by 2 so we get plain old v squared out here. We'll have 18 over 2 x to the 4 plus 18x cubed plus 9 squared. Okay, so now that will mean for us that v squared is equal to, we'll take out 9 x squared since it's in the equation there, and now we're going to be left with so x squared plus 2x plus 1, and as you might already recognize, this is a perfect square, and there you go. That's the first part done. We have shown successfully that v squared equals 9x squared plus times x plus 1 squared. Right. Okay, so for part 2 now, so from part I, we know that v squared is equal to 9x squared, 1 plus x squared. Okay, so to find v on its own, we're going to square root both sides. So we get v is equal to plus or minus 3x, 1 plus x. Now we just have to select which of these we're going to take, because we can't obviously have plus or minus, we need 1. So we just consider our initial values. So v is equal to minus 6, and x is equal to minus 2. And then this reduces down to minus 2 times minus 1, which equals plus or minus 3, 2. Now, since minus is here, we want a minus on the right-hand side. Clearly, we're going to select the negative because this is a positive. So really, v equals minus 3x, 1 plus x is our only option here. That is our v. So now v is equal to dx over dt, and that again is equal to what we just found. So now what I'm going to do is I'm going to reciprocate both sides. So that's flipping them. And now I'm going to cross multiply various things in my favor. So I'm going to choose minus 3 to come over this way, and for dx to come over this way. Now we're going to integrate both sides with respect to their own variable. So if I integrate that and integrate that, so as we know, the integral of 3 is 3t, and then we're going to leave this because we do not know how to integrate this with our 3-unit knowledge. And normally there should be a constant here, but for some reason there is no constant in the question, so we're going to leave it like that. But that is how we do part 2. So as we've shown, minus 3t is equal to the integral of dx over x times 1 plus x. Okay, for the last bit now this is probably the hardest bit of the question, which is a good thing, because we've been told various things already that could help us with part I and part II. So alright, so now for part III. So it can be shown for some constant c that ln 1 plus 1 over x is equal to 3t plus c. So more or less they've shown us that the integral of this is in fact this thing. Okay, so now we have to find c. So we're going to use our initial values again. So when t is equal to 0, x is equal to minus 2. So now we just substitute in the respective variables. So we've got ln a half equals c, or if we want, we can do minus ln 2 is equal to c. So now that we've used that, we just need to express x as a function of t. So we're going to replace c now. So if I grab my eraser, I can take that out now. And I'm going to replace c with minus ln 2. Now I'll bring the ln 2 over to the other side. Get 3t here. Now, as you know, the sum of two logs is equal to the log of the product of them. Which is equal to ln 2 plus 2 over x plus 3t. Now, since we want x as a function of t, we're going to have it in exponential form now. So if you know how to do that, we take it. So that now 2 plus 2 over x is the logarithm of e and whatnot. Okay, so now we take e minus that. And now I'm going to flip both sides. And finally, I'm going to bring 2 from the right-hand side and multiply it. So therefore, we get that x is equal to e to the 3t minus 2. And that's it.